Today we're going to learn about spanning trees. Think about when you're running electrical wires so multiple devices can receive electricity. Typically have a picture something like this whenever you run multiple wires. With spanning trees, essentially is the same concept, creating the most efficient system by using the fewest amount of wires. So here we have the task. Your company must run Ethernet cables to 5 different offices so that all 5 offices have high-speed internet access. For each computer to be on the office network, there must be a way to get from each computer to the other computers by the following cable. So one worker proposed running cable between the 5 offices as illustrated in this following diagram. The vertices represent the offices, and the edges represent segments of cable. So here, how many lengths of cable or edges are used, and explain why this is an inefficient way to run the cable. Let's take a look at each vertex. Suppose we have this vertex right here. How many cables are connected to that computer? Well, there's 1, 2, 3 cables connected. And think about whenever you connect cable to a computer, you most likely only need 1 cable to receive internet, not 3. So this is an inefficient network or an inefficient way to run cable because there's too many wires going to the same computer. So our task is to design a more efficient network and indicate how many lengths of cable are used. So here's that office diagram that was submitted before. And so here are the 5 offices without any cables. Well, so we just need to make sure each office is connected to another office. And so we have these 2 offices connected. We have these 2, and then if we just keep going, we go all the way across. And then now we have all 5 offices connected to where you can get any of these 5 offices running cable in this pattern. So here there's going to be 4 cables used, as opposed to the earlier 8 cables. There are several different options. This is not the only possible answer to this question. We have this design, again, it's still just 4 cables. This design, again, 4 cables. This design, and I'm sure there's several others. The most simple task that you're going to have is take a layout. In this case, we're going to just suppose that they're offices and we need to provide them with internet. So this is the easiest type of problem you're going to get, where you have this grid of vertices and you have to add the edges. We'll do this a few times just to kind of give you an idea. And there's more than one way to answer this. So these spanning trees, essentially what we're going to start doing is just connecting cable to these offices. And here, each office can be reached by any one office. When we go down to number 2, we have a very similar problem. And we just try to connect all these offices with internet cable. As we move on and get a little bit more difficult diagrams, we just continue to add the cables until we have no cycles in this graph, or in the graphs that we're given. Cycles will be defined here in just a minute. But cycles are like miniature circuits throughout the graph. So we want to just make sure that we don't have any circuits of any kind in this graph. We don't want any loops, no circles, no enclosed figures. Those are what cycles are. So to be specific, a cycle in a graph is a path that starts and ends at the same vertex and does not use any edge more than once. This is a lot like the Euler circuits, except it doesn't necessarily have to use the entire graph, just a portion of the graph. So we want to create a spanning tree by eliminating the cycles. If you take a look, there are several small loops throughout this entire graph. We have a loop right here. We have a loop right here. There are loops all the way around this thing, and again, those loops are called cycles. So we want to eliminate the cycles one at a time. Take a look at the red pieces of cable. We're going to eliminate those. And so we have eliminated just a couple of cycles there, and we'll just keep eliminating them one at a time. So if we take off this, you can tell that that little triangle right here no longer exists. So this was a cycle that just got eliminated, and then we'll keep going. If we go all the way around, we can see that we've eliminated most cycles from this graph. But if we take a look, this cycle still exists, that triangle, and then this cycle still exists, this triangle. So here, if we eliminate that line and that line, there are no more cycles that exist, no more little loops in the graph. And here's your final answer. And just remember, to create a spanning tree, you must identify all the cycles in a graph and eliminate one edge of a cycle until there are no remaining cycles in the graph. Whenever you create a spanning tree from scratch, you must make sure that you do not draw any cycles. Because as soon as you draw a cycle, you do not have a spanning tree.